Hi everyone, it's Mrs. Martello. We're going to look at section 2.5 on page 82 in the textbook. So if you want to follow along in the online textbook, you can do that. So today we're going to look at compound inequalities. So the word compound inequality, it means that we're forming an inequality that's joining two inequalities with either the word and or. So the word compound means that there's more than one. So we're going to have two inequalities joined with the word and or joined with the word or. Let's look at and first. The graph of a compound inequality with and is called the intersection of the two graphs. The graph shows that the numbers are the solutions of both inequalities. So if we look at x is greater than or equal to 2 and we look at x is less than 5, think about what numbers would make both of these inequalities true. If I look at one at a time, I would put a closed circle on 2 and I would shade to the right. If I look at x is less than 5, I would put an open circle on 5 and shade to the left. Now look at where these two are overlapping. In this middle section here is where it would make them both true. So it could equal 2. It could be any of these numbers here all the way up to 5, but not including 5 because it's not equal to 5. So we're saying here that all of our possible answers are in just this little space. So it's almost like a segment that's connected with the circles. And in this case, we have one closed and one open. So when I have an and compound inequality, I want to rewrite this as one big inequality. In here, these are where all the x's are, the possible values for x. So when I write my compound inequality, I'm going to put x in the middle. 2 goes to the left and 5 goes to the right. So you always have your numbers with the smaller number on the left and the bigger number on the right. Variable goes in the middle. Now we're going to fill in our inequality symbols. So here x is technically bigger than 2 or equal to 2. So that's why it's open to the x. And then here x is technically less than 5. So this is x is less than 5. So the way that I would read this inequality is I would say 2 is less than or equal to x, which is less than 5. So you use the words which is to connect them. I'll say it again. 2 is less than or equal to x, which is less than 5. Okay, that's for and. Ands are a little more complicated. Ors are a bit easier. So with or, the graph of a compound inequality with or is called the union of the graphs. And the graph shows the numbers that are solutions of either inequality. So it's either one or the other. So here we have y is less than or equal to -2, closed circle shaded to the left. Or y is greater than 1, so we have an open circle shaded to the right. And then we're just going to merge these two together. So the less than or equal to -2 is on the left side. The greater than 1 is over here on the right side. And these show where the solutions are. So they could be a number down here, or it could be a number up here. It can't be in between because it has to be either less than -2 or greater than 1. Okay, so it's either one or the other. Okay, we're gonna look at example 1. We're gonna practice writing these inequalities here, these compound inequalities from the words. So it says a number x is greater than -8 and less than or equal to 4. Okay, so we're going to write two inequalities. So we have a number x is greater than -8. Then we're going to write the word and. Then it says less than or equal to. So they're still talking about x. X is less than or equal to 4. So now we have these two inequalities separate, but with an and compound inequality, we need to join them together. So I'm going to take the smaller number, -8, put it on the left. Take the x, put it in the middle. Take the 4, put it on the right. And now we're going to fill in our inequality symbols. Over here, it was pointing at the -8, so it's still pointing there. And over here, it was pointing at the x, so it's still here. So this inequality is -8 is less than x, which is less than or equal to 4. When we graph it, we're going to have an open circle on -8. We're going to have a closed circle on 4. And we're going to shade in between because x is between -8 and 4. Okay, let's look at B. It says a number y is at most 0 or at least 2. Okay, so let's write this as an inequality. Y is less than or equal to 0, or, and then still talking about y is greater than or equal to 2. And then with an or, you keep it separate because it's either this one or it's this one. You can't combine them together, leave them separate just like this. Y is less than or equal to 0, or y is greater than or equal to 2. Let's graph it. So when we graph, we're gonna put a closed circle on 0 and shade to the left because it's less than. We're gonna put a closed circle on 2 and we're gonna shade to the right because it's greater than. Okay, let's take a look at an example. I think the ands are a little trickier, so why don't I do an and compound inequality here? I'm gonna do number 1. So I'm gonna go down here, we're gonna do a monitoring progress number 1. It says a number D is more than, so greater than 0, and it says less than 10. So they're still talking about D. So we're gonna say D is less than 10. Now because this is an and compound inequality, I'm gonna rewrite it and put it together. So we have 0 is the smaller number that goes on the left side. D is our variable that goes in the middle. 10 is our bigger number that goes on the right side. And let's fill in our inequality symbols. So it's pointing at the 0, still want to point at the 0. Pointing at the D, still want it pointing at the D. So this would be our answer here. And again, I would say 0 is less than D, which is less than 10. That's our compound inequality. Something to note when you write these and compounds inequalities, you should notice that both the symbols are always going to be pointing in the less than direction. And that reason is that because 0 is less than 10. So because I'm setting it up this way and putting the smaller number on the left, the bigger number there on the right, and we're always going to have these less than direction symbols. So it could be less than or equal to. Okay, let's graph it. So I'm going to go over here on my number line. And you can kind of set up your number line however you think. Because I'm going from 0 to 10, maybe I'll go by 2s, or maybe I could go by 5s. It doesn't matter. It's totally up to you what you want to go by. Maybe I'll go by 5s. So I'll have -5, 0, 5, 10, 15, and I can put D at the end just to label my number line. Okay, I'm going to put an open circle on 0. I'm going to put an open circle on 10, and then I'm going to shade in between because it's everything in between these two. All right, great. Let's go over and we're going to take a look at example 2. So in example 2, we're going to solve these compound inequalities, and we're actually going to do the work here together. So this was monitoring progress 1. Now we're going to do example 2, and we're going to look at A. So we're going to solve the compound inequality. -4 is less than x minus 2, which is less than 3, and then we'll graph the solution. So remember that this is a compound inequality, which means it's 2 inequalities joined together. So technically, this would be the first inequality. -4 is less than x minus 2, and I would solve that inequality. And the second inequality would be the middle with the right side. So x minus 2 is less than 3. I would solve that and get my answer. Now I could just leave it together as one compound inequality, but remember when I solve for x, I need to solve it with both inequalities. So I'm getting rid of this -2 with the -4 and with the 3. So here, let's solve for x. I'm gonna add 2. I'm gonna add 2 to the left inequality, and I'm gonna add 2 to the right inequality. So this is why it's a compound inequality, because I have to do it to both of these inequalities. I get -2 is less than x, which is less than 5. And that's my answer for this one. Okay, I'm gonna go ahead and draw my number line so I can graph it. And again, you can set up your number line however you think it's best. Maybe this time I'll go by 2s, it doesn't matter. -4, -2, 0, 2, 4, 6, 8. Okay, I'm gonna put an open circle on -2. Now 5 is not one of the numbers I chose on here, but I can put a circle where 5 would be, and then just write a little 5 above it like this, open circle. And then I'm gonna shade in between because it's an and X is everything in between these two numbers, just like this. Okay, let's do 2b. -3 is less than -2x plus 1, which is less than or equal to 9. We're gonna solve for x. Okay, so I'm gonna isolate the x here in the middle. First step is to get rid of the 1. Don't forget that I'm solving this with the 9, and I'm also solving this with the -3. So when I subtract 1 to cancel it out, I'm gonna subtract 1 from the 9 and from the -3. I get -4 is less than -2x, which is less than or equal to 8. Let's keep going. I'm gonna divide by -2. Now be careful, this is an inequality. So remember what happens when we divide both sides of an inequality by a negative number, we're gonna have to flip this inequality symbol. So I'm gonna divide this number by -2 and this number by -2. So here we get +2 is greater than x, which is greater than or equal to -4. Now this is backwards, it goes big to small. I'm gonna rewrite it so it's small to big. Put -4 is less than or equal to x, which is less than 2. That would be our answer, just like that. Okay, let's do our number line. And maybe I'll go by 2's again. So -6, -4, -2, 0, 2, and 4. This time we're gonna have a closed circle on -4, an open circle on 2, and x is in between. So I'm gonna shade everything in between here. And there we have it. That's solving our and. Next, we're gonna look at or. Ors are a little bit easier. You just leave them separate and you solve them separately. So let's take a look at example 3. We have 3y minus 5 is less than -8, or 2y minus 1 is greater than 5. And then we'll graph the solution. So we're gonna solve this one first, then this one second. So 3y minus 5 is less than -8. We'll add 5 to both sides. Then we'll divide both sides by 3. We get y is less than -1. Or let's solve the second one. We're gonna add 1 to both sides, and then we'll divide 2 to both sides. We get y is greater than 3. So our answer here, we have y is less than -1 or y is greater than 3. So we're gonna graph it. We're gonna put an open circle on -1, shade to the left. And then we're gonna put an open circle on 3 and shade to the right. So when it's an or, the shading should go in opposite directions of each other with a space in the middle. Okay, let's do one of these together here. So why don't we try number 6 together? We're gonna do monitoring progress 6. We have 2p plus 1 is less than -7, or 3 minus 2p is less than or equal to -1. Okay, let's solve. Okay, I'm gonna keep it separate, solve one at a time. Let's subtract 1 from both sides. 2p is less than -8. Divide both sides by 2. So p is less than -4. I'm gonna carry this word or down so I don't forget it in my answer. Let's solve the second one. Subtract 3 from both sides. This is a +3, so 3 minus 3 would cancel out. I'm left with -2p is less than or equal to -4. Let's divide both sides by -2. Now be careful, we just divided both sides by a negative number, so I'm gonna flip my inequality symbol to be greater than or equal to 2. And this would be my answer just like this. P is less than -4 or P is greater than 2. Okay, I'm gonna graph this. So I think I'm gonna go by 2's again. That seems to be working out well for us. Okay, so we're gonna have P is less than -4. That's an open circle, and we're gonna shade to the left. And then P is greater than or equal to 2. That's a closed circle, and we're gonna shade to the right. And that's solving or compound inequalities.